Now that we know how to write our proofs for algebraic things, we are going to move into geometric proofs. So a lot of times we are going to be given something like this. We're going to be given some information, and then we might be given a picture that also gives us more information, and then asked to prove. So this first example, we're given that the measure of ABC equals 90 degrees. And then we're also given in our picture that ABD equals 8x plus 1 and DBC equals 5x minus 2. And then we're going to ask to prove what's the measure of ABD. That's 57. So we all know how to find this. We need to use certain things that we have learned in order to solve for x and then figure out where to plug in x at. So like I said before, the first statements you're putting into your two-column proofs are going to be the ones that are given to us. So we were given ABC equals 90. Reason is given. We were also given the measure of ABD. And again, it's just given. And DBC, again, that was all given to us. So even if it's something that's in picture form, we're still going to put this in our proof form. Given all of those three things, we know, based on everything we've done with our angles, that it means that angle ABD plus DBC is going to add up to the total of 90. It's the two parts. So there's actually a couple of reasons why, and you can put either one or both, and that's the definition of complementary angles, because we know that they are adding up to 90 and 90 is complementary angles. It is also our what did we call it? We called it our angle addition postulate, that one part plus the other part equals the total part. So either one goes here, definition of complementary angles or our angle addition postulate. So now I'm just solving for x. So going from 4 to 5, all we did was combine like terms. So that's our reason, is combining like terms. And then continue to try to solve for x, adding to one side. What did we do to get to the next step? We added, so that's our addition postulate. Now we need to divide both sides by 13 to get x by itself. What did we do? We divided, so that's our division property. So x equals 7. We're not done because that's not what it's asking us to prove. We are asked to prove ABD, so we need to plug in our x of 7 into 8x plus 1, which is what we're doing in number 8 here, and that is the substitution property. You remember from that first page of properties we did, whenever you plug in our x equals 7 for something, that's substituting. And then when we solve, we get ABD equals 57, and you can just say solve or calculated on this final reason. So there is room here for you to write it in a paragraph proof. I did not do this for you, but to practice that, there is plenty of space here to rewrite all of these statements and reasons in complete sentences. Let's go into the next example. So we're given that the measure of angle ABE equals 6x plus 7, and the measure of DBC equals 8x minus 27. And then we're shown the picture of our two intersecting lines and where those angles are. And then we're asked to prove x equals 17. So let's start. First step, always the given. So we're given ABE. Number 2, well, we were given TBC. Okay. Now the next step, if we look at these angles, the relationship between these two angles are our vertical angles, so they are equal. So step 3 is, in order to solve for x, we need to equal the two equations together. 6x plus 7 equals 8x minus 7. And why are we able to say that they are equal? Because that's the definition of our vertical angles. And these are vertical angles. So next step is getting x to one side. So I am subtracting 6x from both sides from step 3 to step 4. So that's our subtraction property. Still trying to get x by itself. From 4 to 5, I'm adding 27 to both sides. So adding, that's our addition property. Continuing to get x by itself, we need to divide both sides by 2 to get from step 5 to 6. So what did we do? We divided. It's our division property. Remember that the order here on our proofs does matter. 17 equals x. We can flip it to get x equals 7, which is exactly what they asked us to prove, and we flipped it by our symmetric property. So down below, I've just recreated this 2-column proof into a flowchart proof. So you can see each statement. I just wrote in the box and then the reason on the line. So this statement was given, and then each statement and reason, statement, reason, statement, reason, statement, reason, statement, reason. Like I said, it's 2-column proofs are the easiest to lay out, and then you can go into a flowchart from there. All right, let's practice our geometric proofs with our angle information that we did last week, and let me know when you have questions.